Welcome back to Nerf Science. I am Captain Xavier, and we're going to pick up where we left off last time. Last time we were doing an experiment with canted cages. We had two strifes built to identical specs, same motors, same wheels, same wiring. The only difference was that one has a straight cage and one has a canted cage. We then ran a battery of tests. We tested the FPS, we tested the flight path, and we tested for rotation, and we were able to observe that there was a lower FPS, the flight path was a little bit more stable, and we were able to show a significant increase in rotation. Now, this doesn't prove anything. This is certainly not an exhaustive series of tests, nor are the methods that I'm using precise enough to really prove anything, but we were able to make an observation, and from that we could eventually put together a hypothesis which could lead to a theory and all of that. But we're not at nearly that level of scientific rigor here. So today we're going to make one additional change. We're going to leave the straight cage out entirely. That one is not going to be used today. Instead, we're going to focus on a single incremental change with the canted cage, namely that we're going to now use a easy half-dart magazine adapter to fire half darts. So this will now be our control, which will be full-length darts from a canted cage, and we will compare that in the same battery of tests to half darts in a canted cage. Since we already know that there was an improvement with the canted cage, we'll now be able to tell if half darts builds on that improvement and is then further better, or if it's actually a decrement. At least we're going to attempt to observe that. We won't be able to, again, prove anything. There is no proof taking place here. There isn't even a reasonable theory. This is simply an attempt to observe some stuff. So, let's get going. To the chronograph first. Once more. This time with the camera recording. Here we have our control. Canted cage, full-length darts. Let's see what kind of numbers we're getting. 99, 110, 103, 105, 94, 81, 108, 106, 109. So yeah, coming in around 110 is the average. That's what I got the first time. There was an outlier or two this time where a dart came out weird. I think I had that the first time when a dart lost its head. But generally coming in at around 110, which is a perfectly acceptable rate of FPS. Alright, let's see what happens when we switch to half darts. Right, I have the Ezekiel kit in there, so we've got half darts. First time I ran this experiment, I blew the head off of 6 out of the 10 darts. I was using Gen 2 workers, the white ones. So I've switched to Gen 3s, hopefully won't lose as many heads this time. And then I've glued the white ones because we are going to need white ones for the rotation experiment. But let's see what kind of numbers we're getting with half darts. 91, 99, 97, 97, 96, 100, 96, 90, 65, but that one came out weird. 91. So again, we had one outlier coming in really low, but everything else was in the 90s to 100s range. So we are losing around 10 FPS going to half darts, which is the prevailing hypothesis, is that the shorter darts means you don't have as much time in the flywheels, and so they go a little bit slower. Let's see if we can see a noticeable difference in flight path. To the range! Alright, we're on the range. We're going to do a 5-round burst, nice and slow with full-length darts, and then a fast burst, and see what we can see. Oh, those are just beautifully straight. Quick burst. Oh yeah, those fly beautifully, no deviation at all. Very, very nice. All right, let's try half darts. All right, I'm back, lunch happened. So now we're gonna try the same thing, but with half darts. Again, a slow 5-round burst, and then a fast 5-round burst, and we'll see what we get. Had some issues that were really, I think, attributed to the pusher. we will have to take that into account. Let's go take a look and see what happened. All right. We have our first outlier that only came in here at about 35 feet. And we had another that came in short at about 65 feet. But then we get to the regular ones. We have here at 75 is where we start seeing the first of the full-length darts. And then we have some half-larks. We had one that snuck out that way a little bit more, and another one there, and that could have just been where they bounced. But then when we get here at 100, we see half darts and full-length darts here. So despite being 10 FPS lower, we're getting the same range. And when they properly stabilized, they seem to fly just as good and as straight. But there were more outliers, and we'll discuss that at the end because I had a realization. So let's go to the last experiment. Train! So let's talk about my overall observations. I honestly didn't notice that big of a difference between the full-length darts and the half-length darts. The FPS was about 10 lower on average, which is not surprising. That's something that I've heard, that having less time in the flywheels means that not quite as much energy is imparted to the half darts, but they do also have less mass, which means they have less inertia, so a little here, a little there. But it was definitely came in about 10 FPS lower. But then on the ranges were about the same. I was still easily getting 100 feet with these at a slight angle. They were getting the same max range as the full-length darts, so the FPS didn't seem to have that big of an effect on the overall performance. Flight path, as far as I could observe, it doesn't show up well on camera, and it is very much the least scientific of the experience that I ran. They flew nice and straight once the flight path stabilized, and at long ranges they were quite good. Now I did run a short experiment where I was firing at close range, at 25 feet, where the flight didn't have as much time to stabilize. And I noticed some interesting stuff there, but since I didn't run that in the first experiment, I didn't want to introduce it into this one. But that may be something that I look at in the next experiment. Straight and canted flywheel cages, comparing 25 feet, 40 feet, at different ranges, and seeing what kind of a difference it makes if they're not given enough time to stabilize. That will probably be another experiment. So yeah, FPS was lower, flight path was about the same, and then looking at the slow motion footage from the watching them spiral, they seem to be very similar. There were a few outliers where the short darts seemed to have a whole lot more rotations, and a few where these had fewer, but in general it seemed to be about a dozen rotations in that length, that distance, which was probably about 20 feet. So it is a significant amount of spin, but it didn't seem to be that much different between the two, which honestly kind of surprised me, because I was expecting that, like the FPS being lower, having less time in the flywheel might impart less spin, but that didn't seem to be the case. And again, having less mass, it's easier to start them spinning because they have less inertia. So it may have ended up balancing out. I don't know. That's the thing, is I don't have anywhere near the equipment to be able to prove why that ended up being the case. I simply don't have the equipment to measure that. But the observation was that it didn't seem to make that much of a difference as far as I could tell. Which means we fall back on one of the advantages of half darts, which is that they take up half as much space. You could carry a lot more half darts in the same amount of space. And it seems that the performance increase that you get with a canted cage seems to balance out. So next time we will look at some other variable. I may, like I said, try shorter range versus long range and seeing what that does. I may try to introduce some sort of a dart guide and see if that eliminates some of the whirly-birding that I have seen. I didn't see a whole lot of it. I might try a different half-dart system. Instead of using the integrated pusher, putting in, say, the Devil Z Nerf Works hybrid pusher, and then using just a universal adapter, and seeing how much of a difference that makes. Like I said, it's important that you only introduce one variable at a time. Using this kit was kind of another variable because it did alter how the pusher worked. And so one could argue that some of the issues that I ran into with whirly-birding and bad releases and all of that may have actually been the result of this as opposed to the darts in a canted cage. And I'd like to try the whole thing again with a Devil Z Nerf Work kit, half-dart hybrid pusher, and see what I get with that. If you guys have any ideas of a single variable you would like to see introduced to these experiments, let me know, and I will add it to the list potentially. So there are my observations. Take it or leave it. Definitely don't feel that anything was proved. I definitely don't actually really have what I would call a hypothesis. My observations have been that the canted cage does actually have some merit, potentially. But I have no way of saying how much and whether that is actually worth it. But these are my observations. Hope these are perhaps useful to somebody or thought-provoking or, you know, you just found the video interesting. And thank you guys for watching.